This next video lesson, we're going to talk about sharing electrons. We're going to talk about sharing electrons between two elements when they're in a bond. Now, when we say share with your siblings, we're usually like fighting over a toy. As you can see, there's a couple of brothers here fighting over a fire truck. But in chemistry, we don't mean equally sharing. In fact, more often, the electrons are not being shared equally. There are only very certain circumstances where the electrons are being shared equally between two elements. Oftentimes, one element has a greater pull on the bonded electrons than the other element does. And we have a tool for that. We've learned about it in the past. It's called electronegativity. So today we're going to talk about how atoms share electrons when they're in a bond, but also how a molecule distributes its electrons based on how the bonds are sharing their electrons. When two elements are sharing electrons, but they're sharing unequally, we call that term polarity. Now, polarity means that there's an unequal sharing of electrons. Now, if two elements are sharing their electrons completely equally, then we say that that molecule is nonpolar. So polarity is a quantitative value that we can use to determine how much one element is pulling on the electrons compared to the other elements. Another way to imagine polarity is imagine a molecule with two distinct sides or two distinct poles. As we know, the Earth has a north pole and a south pole. Those are two distinct sides of the Earth. Well, a bond has a positive side and a negative side depending on how those electrons are being shared. Let's take a look at three examples here that we have across the bottom. This first one on the left is chlorine bonded to chlorine. Now, both of those elements have the same pull on the bonded electrons. Remember, in a previous class, we talked about how electronegativity is a measure of how much pull one element has on the bonded electrons. Well, let's just say, for example, the electronegativity value of chlorine is 3.5. So in other words, this chlorine is pulling 3.5 in this direction, and this chlorine is pulling 3.5 in that direction. Actually, I was mistaken here, because we have a periodic table of electronegativity values on the back of our periodic table. And if you look, chlorine actually has an electronegativity value of 3.1. And so we have an equal sharing, or basically a tie. If you take the two electronegativities and you subtract them and it equals 0, then it is considered a nonpolar bond. Now let's take, for example, this next one where you have two obviously different molecules. Now the size doesn't necessarily matter, but it's how much they pull on the electrons that matters. Now chlorine, once again, has an electronegativity of 3.16, but hydrogen has an electronegativity of about 2.2. Now, because chlorine has a higher number, well then it's pulling on the electrons with greater force in the right side direction, whereas hydrogen's pulling weakly on the electrons with a strength of 2.2. And because these two vectors don't necessarily cancel each other out because one is larger than the other, then what we have is a polar molecule. Now we represent a polar molecule with an arrow over the top of the molecule that points towards the more electronegative element. And then we simply just cross the tail in this like positive symbol to represent the less electronegative element. But this is the symbolism that we would use to represent a polar molecule, pointing towards the more electronegative element. Now there's another notation that we use in chemistry to represent the polarity, and sometimes you'll see it in a textbook. And it's like a little squiggly lowercase d. That means partial charge. That means that it's not a full charge, it's a partial charge. And if the element is pulling on the electrons more than the other, then it has a partial negative charge. And that means that the other side of the bond has the partial positive charge. So we say chlorine has a partial negative and hydrogen has a partial positive, or you could show the arrow pointing towards more electronegative. These two symbols, the arrow and the partial charges, mean the exact same thing. So you might see both used in context in our class. Now finally, if the electronegativity is so large in chlorine compared to the other element that it's bonded to, in this case sodium, then chlorine is going to completely remove the electron from sodium. And in that case, chlorine becomes a full negative charge. This isn't a partial negative charge like it was in this last one. This is a full negative charge because the electrons have been removed from sodium and have been taken and given to chlorine. And so sodium's a +1 charge and chlorine's a -1 charge, and they're held together by their opposite charge in the form of an ionic bond. Now if you look down here at the bottom, we've got a little scale to help you If you're taking a look at two elements and you subtract or take the difference in their electronegativity, and that difference in electronegativity is 0, well, we consider that a nonpolar covalent bond. But if you have any difference in electronegativity that's greater than 0, then it begins to become more and more polar. Technically, below 0.4 is still considered nonpolar because the difference isn't strong enough to be considering that one element is pulling any stronger on the other. But once you get to 0.5 and up to 2.0, the pull or the unequal sharing of the electrons between the two elements is considered a polar covalent bond, which we talk about right here, electrons being shared unequally. And anything above 2.0, we consider or classify as a full-on ionic bond. Now let's scroll up here to give ourselves a little bit more room, and I'm going to do a couple of examples here. Let's say, for example, you have the molecule NH3, which has nitrogen in the middle, and it's got 3 hydrogens and a pair of electrons on the nitrogen. Now when we talk about the bond polarity, we're looking at just one of the NH bonds. And so we're taking a look at H bonded to N. Now this is happening 3 times in the molecule, but you only calculate the bond polarity once. So you use your periodic table and you look and find the numbers. Nitrogen and hydrogen have the following. Hydrogen is 2.2 and nitrogen is 3.04. Now we want to subtract those. And when we do so, we take the absolute value so that the number is always positive. And if you subtract those two numbers, you get 0.84 difference in electronegativity. And according to that, it falls between 0.4 and 2.0. So that is considered a polar covalent bond. Now what about an example like hydrogen chloride or HCl? Well, the same process. You take 2.2 for the hydrogen and you use the chlorine's electronegativity of 3.16 and you subtract them and you get about 0.96 difference in electronegativity. Now that is still a polar covalent bond, but because this number is bigger, 0.96 is bigger than 0.4, oh, by the way, we take the absolute value of these because we never want it to be a negative number. But because 0.96 is bigger than 0.84, then we say that this bond is more polar than the HN bond of NH3. Well, that takes care of this video lesson on bond polarity. Thanks for watching.